What are the new developments in the AI world that you probably have missed? With a new model named Medusa AI that can accelerate the LLMs and stable audio that is proclaimed as the future of AI audio, the progress in the AI world is never-ending. Let's talk about these developments. The world has transformed thanks to large language models. However, using them to generate text can be expensive and time-consuming. Although techniques like speculative decoding have been suggested to increase generation speed, many in the open-source community are hesitant to adopt them due to their complexity. We're therefore happy to present Medusa, a more streamlined and approachable framework for expediting LLM production. Medusa only adds a few extra decoding heads along with a few other ingredients, as opposed to using an additional draft model like speculative decoding. Despite having a straightforward design, Medusa can roughly double the generating efficiency of LLMs. The latest concealed states of the LLM are introduced with many heads by Medusa, allowing for the simultaneous prediction of numerous consecutive tokens. When adding Medusa heads to a model, the base model is frozen throughout training, and only the Medusa heads are subjected to fine-tuning. With this method, massive models can be adjusted on a single GPU. Each head produces a number of top predictions for its assigned place during inference. A tree-based attention technique is used to combine these predictions into candidates, which are then analyzed concurrently. In the last step, appropriate continuations are chosen using a standard acceptance process, and the longest accepted candidate prefix is then employed for the subsequent decoding stage. Accepting more tokens concurrently improves the efficiency of the decoding procedure and lowers the total number of decoding steps necessary. Let's explore the three elements that make up Medusa: the Medusa heads, the tree attention, and the conventional acceptance scheme. What precisely are Medusa heads, then? They are similar to the language model head in the original architecture, the final layer of a causal transformer model, but with a unique twist. They forecast more than just the next token in line. We implement each Medusa head as a single layer of feed-forward network, augmented by a residual link, taking inspiration from the blockwise parallel decoding method. It's incredibly easy to train these heads. Either use the same corpus that was used to train the initial model, or use the model to create a new corpus. Importantly, only the Medusa heads are adjusted during this training phase. The original model stays static. When compared to the computationally intensive training of a separate draft model using speculative decoding techniques, this tailored training produces a very parameter-efficient procedure that converges quickly. The effectiveness of Medusa heads is really extremely remarkable. For predicting the next token on the Vicuna models we test, Medusa heads have a top 1 accuracy rate of about 60%. Nevertheless, there's still an opportunity for development. Why Medusa? Performance is crucial in the quick-paced field of machine learning. A straightforward yet effective architecture called Medusa uses several decoding heads to speed up LLM construction. Medusa addresses 3 main problems with common acceleration approaches. Good draft model requirement. Medusa does away with the requirement for a distinct draft model. System complexity. By adding more heads to your current model, the system is made simpler. Inefficiency in sampling-based generation. Thanks to Medusa's original strategy, non-greedy generation is now as quick as greedy decoding. Medusa may be installed via pip most easily, and Medusa is a simpler and more user-friendly framework for accelerating LLM generation. What happens after creating generative AI technology for creating images and code? It is a text-to-audio generation for Stability AI. Stable Audio, the firm's first AI product for creating music and sounds, was just launched according to Stability AI, the top open generative AI company in the world. Using the most recent generative AI methods, Stable Audio is a first-of-its-kind platform that employs a simple online interface to deliver faster, higher-quality music. Both a free version of Stable Audio that can be used to create and download songs that are up to 20 seconds long, as well as a pro subscription that provides 90-second tracks that may be downloaded for commercial applications, are offered by Stability AI. As the only independent, open, and multimodal generative AI company, we are thrilled to use our expertise to develop a product in support of music creators, said Imad Mostaq, CEO of Stability AI. Today, Stability AI released the initial public release of its stable audio technology, enabling anyone to create brief audio snippets using only basic text inputs. The company behind the Stable Diffusion text-to-image generation AI technology is Stability AI. For better image composition, Stable Diffusion was revised back in July with its new SDXL base model. After hearing that information, the business launched Stable Code in August, broadening its focus to include code in addition to images. The possibilities for producers are endless, but Stable Audio is great for artists looking to produce samples for use in their music. The user-supplied descriptive language prompts and the chosen length of composition are used to generate music tracks. For instance, you might enter post-rock, guitars, drum kit, bass, strings, euphoric, uplifting, moody, flowing, raw, epic, sentimental, 125 BPM, and it would output this tune. The underlying model was trained using music and information from Audio Sparks, a well-known music collection, as part of a collaboration between the businesses that will benefit both parties financially and creatively. The AI algorithm behind Stable Diffusion, the company's more well-known picture platform, also powers stable sounds. However, it was trained with sounds rather than images. Users can use it to create music or background noise for any project. Because songs can vary in length, audio diffusion models often produce audio that is a set length, which is horrible for the creation of music. Stability. The new AI platform enables users to create sounds of varying lengths, necessitating the company's training on music and the addition of text metadata pertaining to a song's beginning and end times. In the past, a 30-second clip of audio could only produce 30 seconds of audio or arbitrary segments of songs. Stability users of Stable Audio now have more control over the song's length thanks to model tweaks, according to AI. Stable Audio represents the cutting-edge audio generation research by Stability AI's generative audio research lab, Harmony, the company said in a statement. The business claims that it trained Stable Audio using text metadata and a dataset consisting of over 800,000 audio files containing music, sound effects, and single instrument stems from the stock music licensing firm Audio Sparks. The collection contains audio from more than 19,500 hours. Stability AI claims that it has obtained authorization to use copyrighted content through a partnership with a licensing business. 3 pricing tiers will be available for Stable Audio. A free version that allows consumers to record up to 45 seconds of audio for 20 tracks per month. A professional level that costs $11.99 and offers 500 tracks that can last up to 90 seconds. And an enterprise subscription that allows businesses to set their own use and cost parameters. Audio created with Stable Audio cannot be used for commercial purposes when using the free version. Other well-known figures in generative AI have experimented with text-to-audio generation before. In August, Meta unveiled AudioCraft, a collection of generative AI models that uses prompts to produce music, sound, and ERM with realistic tones. So yet only scholars and a few audio professionals have access to it. Although it is only accessible to academics, Google's Music LLM also allows anybody to create sounds. A significant portion of Stable Audio's possible use cases will be creating background music for podcasts or videos in order to speed up those operations, similar to existing generative AI audio systems. Last year, Stability AI had ambitions to diversify into the creation of audio, video, and 3D images. How does Stable Audio work to generate new pieces of music? Newton Rex is not new to the area of computer-generated music. In 2011, he founded JukeDeck, which he later sold to TikTok. The technology that powers Stable Audio, however, was developed by Zach Evans at Stability AI's internal music generation research studio called Harmony, not JukeDeck. Using image-generating models to take photos in a particular artist's style is one of the usual things people do. However, customers of Stable Audio won't be able to ask the AI model to create new music that, for instance, sounds like an old Beatles song. Newton Rex remarked, "We haven't trained on the Beatles. That hasn't always been the goal with audio sample generation for musicians." Newton Rex observed that, in his experience, most musicians like to be more creative when beginning a new audio work, rather than asking for something in the vein of the Beatles or any other particular musical ensemble. That's it. What do you think of this cool technology? Let us know in the comments below. For more videos like this, subscribe to our channel. Thanks for watching.